And the most important topic from the previous class is your azeotropic mixture. Now, today, before starting, do you have any doubt? Because this is the last topic that we are studying, Van 't Hoff factor. Do you have any doubt from previous classes in any lecture, in any topic? Yes or no?
No.
Okay. So let's begin this. This is your Van 't Hoff factor. I we represent it by I. And before introducing Van 't Hoff factor, thank you, Austin. First of all, we are going to start this abnormal molar mass. What is this abnormal molar mass? So you are going to write some points with me, which is its definition. Then I'm going to explain. When non-volatile solute is added to solvent. Please do write with me. And it undergo association or dissociation. I'll show how it undergo association or dissociation. Then molar mass of non-volatile solute as calculated from colligative property will be different. It will be different from its normal molar mass. This is known as abnormal molar mass. This is known as abnormal molar mass. So please do write it. And then I'm going to explain with the help of an example.
Done, sir.
Very good. Now see what happens here. If you are going to take 1 mole of NaCl, let's take an example of NaCl, and you are going to take 1 mole of NaCl and put it in a solvent. So it will be dissociated into ions, yes or no? See what will happen. If you are going to take 1 mole of NaCl, its molar mass will be basically 23 plus 35.5. 35.5. So it will be 58.5. This will be the molar mass of NaCl you just did. 1 mole of NaCl. Now, you know that it will be dissociated. So molar mass, 1 mole of this Na plus will have 23 gram per mole, and 1 mole of this will be equal to 35.5 gram per mole. So since you dipped 1 mole of NaCl, and if 1 mole of anything. Now, if you want to take out 1 mole from the solution, either you will get 23 gram per mole, or either you will get 35.5 gram per mole. But you dipped 1 mole of NaCl, which was 58.5 gram per mole. So this is whatever you are getting, either you will you just need to take out 1 mole, either you will get Na plus, either you will get Cl minus, and both are different from this. So this is known as abnormal molar mass. You dipped 1 mole of NaCl, which was 58.5 gram per mole. Now you want to take out 1 mole from the solution, either you will get 23 gram per mole or 35.5 gram per mole, which is different from 58.5 gram per mole. So this is your abnormal molar mass. Is that clear?
Yes.
And this scenario is dissociation. Dissociation, dissociation, you already know what is dissociation. 1 mole dissociated into more than 1 mole, that is dissociation. So we don't need to study more about this, but in association, we will be able to understand more clearly in here. Association. So see what happens. I'm going to take 2 moles of CH3COOH. Can you tell me the molar mass of this CH3COOH? If you are going to calculate, you will be getting 60 gram per mole. 60 gram per mole. 2 carbon is there, that means 24. 2 oxygen is there, that means 32. 24 plus 32. How much it is? 46. Oh, wait a minute. 16, 16, 32. CH3COOH. Let me calculate it. 24 plus 32. 56, and 4 hydrogen is there, 6. 4 hydrogen, so 56 plus 4, 60 gram per mole. Now what will happen, there will be association. This was 2 mole initially, but after mixing them in the solution, what will happen here? This will associate itself, and 2 mole will combine together to form a single mole. 2 mole will combine to form a single mole with the help of hydrogen bonding. What is hydrogen bonding? Whenever hydrogen is nearer to either oxygen, let's say phone, whenever hydrogen is nearer to phone like fluorine, oxygen, or nitrogen, hydrogen will make a special bond that is called hydrogen bonding. So you can see their hydrogen oxygen is nearer to each other, so they will make a bond that is known as hydrogen bond. That is known as hydrogen bond. Now, as you can see, 60 gram per mole. Now it associate to form a single mole, which has a molar mass of 160 gram per mole. Now, what happened? You just dipped 60 gram per mole, but when you are going to take out, you will be getting 160 gram per mole. And this scenario is association. That means from more than 1 mole, you are getting a single mole, or less than 1 mole, that is sorry, not less. When you are giving more than 1 mole and getting less than 1 mole, that is called basically association. It associate basically. More from more you will be getting less, and less from less you will be getting more. That is dissociation, and this is your association. Is that clear? So with the help of this molar mass, we are going to introduce this Van 't Hoff factor. Van 't Hoff factor, we denote it with I, and we will be getting some formulas of this Van 't Hoff factor. Please do write it and let me know when you are done with this. And let me know when you are done with this.
Done, sir.
Very good. Now see, we can easily define this Van't of factor in terms of this abnormal molar mass. Van't of factor. That means I. I will be equal to normal molar mass upon abnormal molar mass on abnormal molar mass. So it's very easy. I equals to normal molar mass and upon abnormal molar mass. So if you get any numerical regarding this molar mass and you want to calculate I Van't of factor, it will be normal molar mass upon abnormal molar mass. If you want to go for this, you can easily, normal molar mass was 60 and after associating it becomes, oh, I got it wrong. No, it doubles itself now, so it will not be 160, it will be 120, sorry. So the abnormal molar mass will be 120, and hence if you are going to calculate the value of Van't of factor with half. Is that clear for this question?
Yes.
Okay. Now we are going to define this I in different form, like in terms of association and dissociation. So Van't of factor can be defined as this as well. Just write it with me. It is defined as ratio of number of moles of solute. You can take moles of solute particles after association or dissociation. Number of solute, number of moles of solute before association or dissociation. So with the help of this statement, we can easily write a formula, mathematical equation with this. I will be equal to total number of moles of particles. Total number of moles of particles after either associate or dissociate. So we can write after either, if it is associating, so association or dissociation, divided by total number of moles of particles before association or dissociation. So it's very easy. So first you are going to write it, and then I'm going to write the formula for this and again explain it, which will be very easy to understand. Yeah, let me know when you're done with this.
Yeah, done, sir.
Very good. Now, if I'm going to take this scenario, if I'm going to take this scenario, the above that I gave you, NaCl, first of all, it should be balanced. Always remember that. This is your Na plus Cl minus. If they ask you, examiner ask you, what is the value of I, Van der factor? So you need to see, first of all, whether it is associated or dissociated. So you can see it is dissociated because 1 mole give you 2 mole. So after dissociation, total number of moles of the particle, 1 mole, 2 mole, divided by, before dissociation it was only 1 mole. So I will have a value which will be equal to 2. Are you getting my point? Now
Yeah.
if you are going to take that example, 2 moles of CH3 double OH, which combines together, like this, CH3 C double O, and again this is your OH, and again double bond O, and this is your OH, and this is your CH3. So what happens here? There will be hydrogen bond between this. If you want to calculate the value of I, you can see it was 2 mole, but now it is 1 mole. So this is association, and after association it becomes 1, and before association it is 2 moles. So the value of I here will be 1 by 2. You can see the value of Van der factor, whether you are going to calculate with the help of abnormal molar mass and abnormal molar mass, or whether you are going to calculate it with the help of number of moles after association or dissociation, both have same value, right? If you are going to see the value of I with the help of this formula, normal molar mass upon abnormal molar mass, you can see 1 by 2. And if you are going to look for this in terms of this number of moles of the particle, you are getting the same value. Are you getting my point?
Yes.
Also, it's very important whenever there will be dissociation, that means you will be getting number of moles greater than the initial. That's why I will be greater than 1. Always I will be greater than 1. And in case of association, you will be getting lesser number of moles than the initial. So I will be lesser than 1 in case of association. It's very easy, right? Let me know when you are done with this.
I'm done, sir.
Very good. Now, I'm going to give, you just need to calculate I for different compounds. Calculate I. So, the first one is I'm going to give you is MgCl2. You are going for you are going to calculate for this. And then LCl3, and then comes your Al2SO4 whole thrice. The value of I, please do it. Answer. What is the value of I for MgCl2? No, it's wrong. You can see you are going to dissociate it first. So Mg will have +2 charge and Cl will have negative charge, but you have to balance it. 2 chlorine is there. Now it is balanced. Now, if you want to calculate the value of I will be equal to number of moles after dissociation. 1 mole of Mg plus 2 and 2 mole of Cl minus. So it will be total number of moles after dissociation 3 divided by before dissociation it is 1. So the value of I will be equal to 3. Please do the rest. Any answer for the next one? AlCl3.
Four.
Are you not able to solve this? Mohammadin and Austin. What you just said?
I got 4.
Very good. Austin, what about you? It will go in Al plus 3 and this will be Cl minus. In order to balance it, you are going to put 3 here. What is the total number of moles after dissociation? 3 plus 1. That is 4. And before dissociation, you can see only 1 mole is there. This is the stoichiometric coefficient. So the value of I will be equal to 4. Simple. Now, if you are going to do this, aluminum will go in Al plus 3 and here SO4 minus 2. Just wait a minute. SO4 minus 2. In order to balance it, it will go like this and 3 SO4 minus 2 and 2 L plus 2. Now I will be equal to, you can see, number of moles 3 and here number of moles 2. So total number of moles before dissociation 5 and after dissociation it is 5 and before dissociation it is 1. So I will be equal to 5. Austin, are you getting my point? Yes or no?
Yes.
Okay, please do write it. Then I'm going to give you a question. Please do this question number 41, which is very, very easy. Any answer from you, Hamamuddin? Very good, Austin. So you can see a Van Hoff factor I for a compound which undergoes dissociation. I told you for dissociation, number of particles increases. So I will be greater than 1. And for association, number of particles decreases. So I will be lesser than 1. So greater than 1 and less than 1 is your answer. Is that clear, both of you?
Yes, sir.
Now the third formula for this amount of factor is Van Hoff factor will be equal to observed colligative property upon calculated colligative property, and this changes a little bit formula. That means basically observed colligative property CP colligative property will be equal to I into calculated colligative property. So the colligative properties, 4 colligative properties we studied, their formula slightly changes, only I will be multiplied. Like for relative lowering vapor pressure, a relative lowering in vapor pressure, relative lowering in vapor pressure. You have got the formula P naught minus Ps, that is pressure of the solution, divided by P naught will be equal to I Van Hoff factor into mole fraction of solute. This is your mole fraction of solute. The next one was your elevation in boiling point. Elevation in boiling point. Now it modified into delta TB will be equal to I into KB into M. And then the next, depression in freezing point. Depression in freezing point. So here delta TF will be equal to I into KF into M. And then again comes the last, that is osmotic pressure of solution. So you know osmotic pressure pi is equal to MRT, but here it will be pi is equal to I into MRT you can write, or CRT you can write. So whenever the solute that is given, if it can associate or dissociate, then you need to consider I. It is very important. Whichever numerical we did for pi is equal to MRT, in that they neither associate neither dissociate. That's why the answer does not change, and it is good. But now if you want to solve question, since the chapter is completed, You need to look for the solute. If it is MgCl2 and you want to calculate osmotic pressure, MRT will be as it is, but you need to calculate the value of I, and value of I for MgCl2 will be 3 that you need to do. If it is CH3COOH, the value of I will be half. Is that clear?
Yes.
Let me know when you are done with this. Can you change this? Are you done with this?
Yes.
Okay. Just wait a minute. I'm going to give some questions to you. Yeah. From very basic, I'm going to start. This is your question. Just wait a minute. Can you see the question? Amamuddin?
Yes.
Okay. Any answer? See, I'm going to explain. It's very easy. You need to tell which one of the following salts will have the same value of Ventov factor as this. So you just need to calculate the Ventov factor of this. I for this. So you know this is your K4FeCN6. This compound is known as coordination or complex compound. There is a whole chapter on this compound in your class 12th. So if you are going to dissociate it, you know K will be in positive. If K will be in positive, then this whole quantity will be as it is. This whole quantity will be as it is, and there will be negative. Now, you know that since 4k is there, so you are going to put 4 here, and you know that total positive charge now is 4 plus, so you are going to 4 negative here, because overall charge should be 0, because in this there is 0 charge. Now if you are going to calculate the value of I, you know 4 mole of this and 1 mole of this, it becomes 5, and 1 mole of this, so the value of I is your 5. Now what you need to do, you need to calculate I for different salts. So I think you will be getting I is equal to 5 in this case. In this case, you will be getting 4. In this case, you will be getting 3. In this case, you will be getting 2. In this case, you will be getting 5. So the answer is A. Are you getting my point, both of you, Austin and Humamuddin?
Yes, sir.
No, very good. Now see the next question. At 25 degrees centigrade, the highest osmotic pressure is exhibited by 0.1 m solution of which? So as I told you, pi is equal to IMRT, and you can see M is constant as given. M is constant, R is constant, gas constant, and temperature is also given, that is 25 degrees centigrade. So it all depends upon I. Just let me know the value of I. The one out of this four have the maximum value, will have the maximum osmotic pressure, yes or no? So glucose and urea will have 0 value because it doesn't dissociate or associate. KCl will have the value of I as 2, and CaCl2 has a value of I as 3, because 2 moles of Cl minus and 1 mole of Ca plus 2. So the answer is A. Are you getting my point? This is how the question will be asked. Is that clear, everyone? Austin, is there any doubt? You're not responding at all, Humamuddin. Okay.
No,
If you
sir.
don't, okay, that's good. If you don't get it, just let me know. Because this topic in this chapter is quite important. This is the next question. You just need to play with the formula. I is also not given, so don't worry about I. Any answer? No answer. See, it's quite easy. Pi is equal to, MRT, right? M is what? M is number of moles of solute upon volume of solution in milliliter. Why I converted into this? As you can see, there is volume. Also in the option, there is no number of moles. So now I'm going to do this. Given mass, let's say given mass is M2 and molar mass, let's say M or M2 you can take. Volume will be as it is RNT. And what is this? This is the molar mass, molecular mass. You can see molecular mass of M2 will be written RT upon pi. So the answer is quite easy. You just need to open the formula and write the things. Are you getting my point?
Yes,
Both of them. Okay. Can I change the slide?
yes.
Are you done with this? Are you done with this? The next question.
No, sir.
Okay, I'm waiting. Okay, will you be able to solve it? Yes or no?
Yes, sir.
Okay, take your time.
No, sir. Can you show?
You are not able to solve this? See, it's
No, sir.
very easy. Out of the following 0.1 m aqueous solution, which one will exhibit largest freezing point depression, in which there will be largest freezing point depression. So it's quite easy. You can see 0.10 and delta TF, delta TF will be equal to, what is this? Delta TF will be equal to KF into I into KF into M, right? Yes or no?
Yes.
Tell me. So you just need to calculate the value of the I, the one with the highest value of I. This is your glucose, it will not be dissociated. If you are going for K2SO4, can you tell me the value of I for this? 3 it will be. What is the value? You should think about this. Uh, what is the value of I? KCl will be converted into K plus Cl minus. If you are going to fight right now with these questions, then it will be very helpful in other chapters also. So if I'm asking you, please do let me know about others. You just don't need to deal only with the answers option, the option which is your answer. You also need to think about the other options, what it is actually that will develop your mind or knowledge as well. Now, if you are going for this, Al2SO4 whole thrice, it comes quite few times. So I is equal to, it will be 5. So maximum it is. So C will be 0. Because delta TF will have the maximum, or that means largest freezing point depression will take place in here because of this I. Are you getting my point, Humamuddin, Austin?
Yes, sir.
Yes.
Okay, okay. So now I'm gonna give you some questions of NCERT. Are you solving NCERT? Yes or no? Yes or no? You should solve NCERT as well. And in the next class, where do you solve the questions? In a notebook, right?
Yes, sir.
Yes.
So I'll be checking your notebook. That doesn't mean that means basically I'm gonna give you question number 1, since we have class directly on Tuesday. So there are 41 questions. How many questions can you do till Tuesday? Just let me know. There is total 41 questions. And how many questions? 10, 20, 30. How many questions can you send me on Sunday, coming Sunday? Be honest to yourself and to me, and let me know. Austin and Mohammed, please do let me know.
Sir, 10 to 15, I think.
10 to 15. Sir, I have a test next week. So at least Austin, you can do 15 questions. 15 question is nothing. It will cost you 1 hour, 2 hours. I think you should, you people should, both of you should do a little hard work, because it's your board, and this board marks will be moving around you. We're going to submit. And it's not necessary you are going to do question number 1 to 15. I want you to solve 15 question out of this 41, out of this 41, and that should be solved. I think you can do that. It's not like that you are going to do 1 to 5 questions, 6 questions. Since the chapter is completed, you are going to solve 1 to 15 and never take help from solution. Are you getting my point? If you just stuck in any question, just leave it, and please on Sunday, you are going to submit this in PDF form. And you don't need to write the question. Don't write the question. Just write the question number, like question number 1 and solution is start. I have question. I will look into it and I will check the solution. Okay. And be specific about your question. Like don't go for calculator till class 12th. And after that, it will be allowed in your college. So please don't use calculator, and try to explain the solution as much as you can. Don't use shortcut as well. So these are some points. If you are going to follow for the whole year, it won't what we say. You'll be getting more than your expectation, the marks. Okay. So this is it for today. There will be test for